Hello and welcome back to the Home Lab. What we're going to do today is to have a short look at how to use the screw gauge micrometer. So this is a device that most students and even some training engineers are really rather nervous of. But in fact, it's really easy to use if you just follow a few simple steps. So let's get started. So step one is to find out what units your micrometer is measuring in, although you'll probably be given the right one anyway. But if you were to just pick one up, the way to tell is to look either on the C-frame, it's sometimes printed on here, or on the rotating thimble. And if I look at this one, on the thimble, it says metric. So I know I've got a metric micrometer. Okay, so step two is to see whether your micrometer's got a zero error. And it's good practice to store them with a gap here, which is what I always do. So we're going to close that gap up to zero. And to start to do that, we're going to turn the knurled knob on the thimble here until the spindle and anvil face are fairly close together. And so we don't force them too hard together, we're then going to use the ratchet on the end. And it's always good practice to use the ratchet here, so we can't force them really tight together. And now we can have a look at the scale. I'll show you a photograph in a second to see whether there's a zero error. So step three is to find out what the calibration is on the scale of the micrometer on the thimble. And you'll normally know that, of course, because you'll be using it frequently. But if not, you're just handed one, it's a good idea to check. So what you do is you have your micrometer set to zero, which you've just checked. And then what I do is I wind back one rotation and look at what the numbers do on the thimble. And on this one, as you turn, they go 10, 20, 30, 40, 45, and then they go back to zero, a sort of 50th position. So what does that mean? Well, what that means is we are rotating in hundredths of a millimeter. So one rotation is 50 hundredths. So if you do a second rotation, you've now got 100 hundredths. So the way I think about that is, with the micrometer I've got here, I've got to rotate twice to open the gap here by 1 millimeter. And it's good engineering practice just to have a bit of a look and to go, yeah, that looks like 1 millimeter. It's not 1 centimeter or something like that. So step five, let's make a measurement. We're ready to go. So I'm going to measure the diameter of this unlabeled drill bit I've got here. So what you do is open up the micrometer wider than the item you're going to measure, and then hold the item in the jaws of the micrometer. It's easy to do on the bench, obviously. And you can take up the slack with the knurled knob here, but when you get close, close up with the ratchet so you know you've got a fixed force. So we've now got this set for the diameter of this drill. What we need to do now is to interpret the scale to find out what diameter it is. Okay, so step six is to use the scale on the micrometer to work out the diameter of the item you're measuring, in this case the drill bit. And if you look at ours, we look firstly at the top scale on the sleeve, and you'll notice it's marked in millimeters, and you sort of remember how many you've passed as you unwind the thimble, and in this case we've passed 6 millimeters. But you'll also notice that on the bottom of that scale are 0.5 millimeter little lines, and if you look there, we've passed another half again, so we're at 6.5 millimeters. But we're further on than 0 on the thimble. We've actually got to 10. So this is where you have to sort of keep a few numbers in your head. We've done 6 millimeters on the top scale, an extra half on the bottom, so that's 6.5. And then we've rotated that little bit more, 10 hundredths of a millimeter. So 6.5 is 6.5 millimeters plus that extra tenth of a millimeter. So this drill bit is 6.6 millimeters in diameter. So I appreciate that wasn't that easy, and it's one of these things you've just got to practice. In fact, micrometers aren't that expensive if you buy a sort of fairly low-end one that'll do most jobs that you want to around the house and the workshop. And so it's actually worth just buying one and having a play and measuring a few things. You'll notice here I'm measuring something quite thick. So don't get it into your head that micrometers are only for measuring very, very, very tiny things. But what I'm going to do is I'm going to do another example now, and I'm going to do an example of something that's more typical in school laboratories, measuring the diameter of a wire. Now that's something that's very, very thin indeed, and we're going to see if we can get an extra decimal place, or at least one decimal place with our micrometer. And the method is exactly the same, so once you've got the hang of doing this, you'll be good at using a micrometer. So I've got a reel of wire here, and what we're going to do now is use the micrometer just as another practice example to measure the diameter of this wire, and we're going to see just how precise we can make our reading. Okay, so now let's quickly do the wire. So the thing to do is to open up the micrometer a little bit further than you need to. Sometimes I look at the scale to see how many times I've rotated it, so I sort of know what number I'm at. And then put the wire in the jaws. Now obviously if you wanted a really good reading of the diameter of the wire, you do it in multiple places, but I'm just going to do it once. And then tighten up, and it's best to do it using the ratchet at the end here. And then what we're going to do is take a photograph and have a quick look at what reading we've got. So let's have a look at the reading. Firstly, let's look at the bit that doesn't rotate, okay, the sleeve, and the top scale, and you'll notice the 0 almost completely uncovered, but it hasn't gone past the first line up there, the millimeter scale. So this is less than a millimeter in diameter. So now look at the scale below that, still on the sleeve, the bit that doesn't rotate. And you'll notice we've almost uncovered a ½ millimeter, but not quite. So what that means is that we've rotated almost one turn, but not quite one turn, not quite ½ millimeter. So if you look closely, we've gone past 10, 20, 30, 40, and we've even gone past 45. So this wire has a diameter slightly bigger than 0.45 millimeters, but we've gone to 0.46. And then if you look between the gradations, is that about 6/10 up? So if it is, this would be past 45, so to 46, and a little bit more, maybe 6 bits of that one division. So this wire has a diameter of 0.466 millimeters. So just a few things before we end. I did mention that micrometers are not used just for measuring very, very tiny things. What they are is very, very precise, and you can get different sizes of C-frame, but this is the one you normally see in school laboratories. The other thing is, please don't get it into your head that micrometers are really, really accurate. Okay, I think you know where I'm going here. Micrometers are very precise. The scale on it is divided into very tiny differences. But if those differences have been marked on incorrectly, in other words, the incorrect numbers, then it's not accurate at all. So you need, of course, to understand the difference between accuracy and precision. But of course, most micrometers are set up correctly, the zero error is taken account of, and they are both very accurate and very precise. So I hope you found that video on the screw gauge micrometer useful, and with a little bit of practice you'll be really good with it. So I'm going to end now, but if you want to stay past this little segment of the video, what I'm going to do is tell you a few stories about experiences I've had with micrometers, and I'm also going to put some photographs up of different measurements so you can try and work out, looking at the scale, what the micrometer's reading. Anyway, I'll be making another video soon. Stay if you want to, and I look forward to seeing you next time. So a few little bits at the end, and firstly my story about micrometers. I was lucky enough to go out to the Honduran rainforest many years ago, and the scientists out there were measuring all sorts of things, and one of the things that they were measuring was dimensions of animals, and they were using something very similar to a micrometer, a vernier caliper, which uses a scale that's not dissimilar. And the reason I'm telling you this story is, one or two of you might be saying, yeah, but you can buy these with a digital scale on that you can read out. So why bother learning everything we've spoken about today? Well, it was hot, it was humid, and the electronics just didn't work at all. Everything went rusty very quickly, batteries failed, we couldn't get replacement batteries, obviously, in the middle of the rainforest, and neither did we want to take batteries and create more waste, as it were. Whereas, as long as this is reasonably lubricated, it's not going to rust, and you can use it anywhere, and the batteries aren't going to fail because there's no electronics. So I would always go for screw gauge micrometers and vernier calipers that aren't electrical. Now, the next thing you might say is, why bother with all these complications with the micrometer when you can buy something like this that's got holes in it to measure the diameter of things like drills and bars? Well, firstly, it's a bit of a ready reckoner, and I use these a lot, but they don't have the precision, and they don't go down to many decimal places. You can only do a few widths with these. The micrometer will be much more precise and will go right the way down to fractions of a millimetre. What about wires? Well, yes, you can get wire gauges as well, but again, it's a quick ready reckoner, this. It's not going to give you the exact dimensions that you need. So I would always be good at using a micrometer. So let's have a quick discussion about zero errors. This micrometer has been screwed in the full way with the ratchet, and the spindle and anvil faces are touching each other. But it is actually already reading 0.05 millimeters. That reading is going to be additional to what we read, as we're going to start winding out from this point. So with this kind of zero error, to get our measurement, we need to take this much off our scale reading when we use the micrometer. And this micrometer, if you look at the photograph, is zero errored in the other direction. So when it's actually screwed up correctly to where it should be on zero, it's actually reading 45 on the scale. So we actually need to turn this micrometer further to get to the 0 point. So we need to remember that on all of our measurements, we need to add 0.05 to compensate for the zero error. One final bit about zeroing micrometers is that in the box you often get a little spanner, and these get lost, and most people don't know what they're for. But there's a little hole here in the sleeve, and you'll find out now why it's called the sleeve, because you can put the spanner in that little hole, and I won't do it on camera, but you can push and rotate the sleeve so the zero on the sleeve lines up with the 0 on the thimble, and your micrometer has then been re-zeroed. And finally, I'm going to put a few photographs up in a moment, and I'll leave them on the screen so you can look at each one slowly and see if you can work out what the diameter is of the object that we're measuring. It will be off screen, and then I will give you the answer. So get yourself a micrometer. Learn how to use it, and in fact it's like a lot of things in life, that if you can spend the time just working out how they work, and often I have to do that every time I pick up a new one, I have to remind myself, it's very satisfying knowing how to use one, and it's another great skill to have in the laboratory. Anyway, see you soon, and I hope you enjoyed the video. Oh, just one thing I wanted to add, and I suddenly thought about this whilst I was finishing off the video, is the micrometers that you come across tend to be inherently right-handed devices. So if you're a left-handed person, you're going to find them quite annoying because the scale will sort of be upside down. Maybe they do have left-handed ones out there, I don't know. But you guys are pretty clever anyway, so I'm sure you'll be able to work it out.